And welcome back guys to another video. So here I'll be doing my usual complete walkthroughs on this paper, and this is the Maths Paper 3 June 2017. And again, this is from the 9 to 1 series, so you know, as usual, just follow through and I'll be completing every question as we do it. One thing I want to note is that this is a calculator paper, so make sure you use a calculator for, yes, even the easy questions, because you want to avoid any silly errors. And trust me, the mark scheme really will penalize you if you don't use a calculator or simplify the best way you can. Anyway, without further ado, let's just go straight into it. And yeah, use a black pen, guys. Yeah. So, so right off the bat, we'll go Venn diagram. Now, notation wise, for those who don't know, this sign here, this squiggly Greek letter, is actually known as the universal set. Now, the universal set means that all odd numbers are less than 30 must be here in one capacity or another, whether in the circles or out of it. So let's just have a go and do this as we do. So let's look at set A. So let's label the left circle set A and set B. Now this tells us that A has these elements and B has these elements. The first thing you want to do is find what do they both have in common, i.e. the intersection part, which is the middle. So let's see, they both have a 15, so that's good. So you write 15 here, and yeah, that's it. So they only have 15. Now what does A have exclusively? Well, it has a 3 and a 9, a 21 and a 27. B has exclusively a 5 and a 25. So far so easy. Now for the outside part of the Venn, remember that everything in this entire spectrum must have an odd numbers less than 30. So let's put numbers that weren't included. So let me just change the color to red. So let's start from 1. So is there 1? Nope. 3, yep, it's checked out. 5 is checked out. 7, nope. 9 is checked out. What else do we have? 11, nope. Let's see, 13, nope. 15, yep, it's checked out. I already crossed it. 17, nope. So again, just put all the numbers that are in there. So 19 as well. 21, yeah, it's inside. 23, nope. 25, done. 27, done. And 29. And that's it. So these are all the elements that should be present. Okay, let's move on. So let's have a look. So a number is chosen at random from a universal set. Okay, what is the probability that the number is in the set which says A, U, B? So this actually means when A and B unites. So this is the uniting set. There's another notation which you might see, which is A and B, and this is the intersection set. The difference between this is that the intersection only deals with the things that's intersecting, i.e. the 15. Whereas universal set means A unites with B, so everything in A, the middle sect, and B. So let's just count. So inside A and B, we got AUB, we got 1, 2, 3, 4, 5, 6, 7. So we got 7 elements. And how many is there altogether in the universal set? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wait, only 13? Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 7 out of 15. That's it. That should be the correct value. So always double check your counting, yeah? Okay, let's move on. So number 2, solve the simultaneous equations. So these are easy because these are nice and line up for you. So the key idea is make sure you have the same values in front, the coefficients. So they both have 3x, and we just want to subtract this to get rid of the x's or the y's. So let's just go ahead and do this and put a subtraction sign. So minusing this, what happens? So 3x take with 3x is 0, because that's what we want, is nothing. Y minus 4y, so this means y minus y, so it means plus 4y, so it'll be plus 5y. And then minus 4 minus 6 is minus 10. Again, put this in the calculator. Now finally, this means we have 5y equals minus 10. So just divide by 5 and you should get minus 2. Now all we want to do is plug this minus 2 back into the equation. So let's just pick an easy one. I'm going to pick the first one because it just looks easy to work with. 3x plus y. So rewriting that, we can have 3x plus, and put this in a bracket if you want, minus 2 equals minus 4. Now expanding this one, we have 3x, and just plus minus means minus 2 equals minus 4. Add, and then to move, so literally move every number to the right and isolate the x. So plus 2 across, so we have 3x equals minus 4 plus 2, which is minus 2. Divide by 3, x equals minus 2 over 3. And that's it, guys. These are our x and y values. Okay, so far so good actually. I think we're actually on a roll so far. Okay, number 3. So the table shows some information about the dress sizes of 25 women. Okay. Find the median dress size. Okay, buzzword. Median means the middle number. So this is literally the out of the 25 women, you want to find the middle person. And to do that, we just need to half it. So in your calculator, put 25 over 2. Or for you guys, you can also write 25 plus 1 over 2. Same thing. This will give you the 12.5th woman. In this case, this will give you the 30th woman, which again, round up to the same. So in order to get this, you literally just put these numbers in ascending order, count them up, and see where the 12th woman would lie. So let's put this order. So from dress size 8, we have a total of 2 women. Up to dress size 10, we have a total of 2 plus 9, so 11 women up to this point that's been accounted for. And for the next set, up to 12, we have a total of 2 plus 9 plus 8 women, so 11 plus 8, 19 women. So yes, this must mean that the 13th woman must lie in this group, because this group accounts for the 12th to the 19th woman. So we can say that the median dress size is 12. It's easy. You also do the same method for quartiles, yeah? Okay, part B. So 3 of the 25 women have a shoe size of 7. And just to relate this back, remember this information is about dress size, yeah? So just in case they talk about combining it, you would say they're mutually exclusive. So Zoe says that if you choose at random one of the 25 women, the probability that she has either a shoe size of 7 or a dress size of 14, so 2 different variables, is 9 out of 25, because 3 out of 25 women have a shoe size 7, 6 out of 25 have a dress size of 14. So they got the 6 from here. Does this add up to 925? It does, but this statement is false. This is not correct. Why? Let me get my pen. It's false because these are 2 different variables, okay? You cannot add probabilities to 2 different variables. So no, because both categories, is that how you spell categories? Oh god. Yep, are different. So we say, so the correct term is mutually exclusive. Mutually exclusive means that they are completely away from each other. They have no relevance to each other. And this means that some of the women that has a shoe size 7 may also have a dress size of 14. So that's another thing as well, yeah? So always add as much detail as you can. Okay, I guess you could also say some women may be a size 7 in terms of shoes and a size 14 in terms of dresses. So this could be a problem. And that's it. Okay, number 4. So Daniel bakes 420 cakes. Okay, let's get our calculator ready. He bakes only vanilla, banana, lemon, and chocolate. Now, of these, 2/7 of the cakes are vanilla. So this means for the vanilla cake, 2/7 of 420 of vanilla. So we can, of course, put that in a calculator. So 2/7 of 420. So this literally means 2/7 times 420. And that should give us 120 cakes. So that's 120 counted. 35% are banana. So for banana, put in your calculator, 35% of 420. So you should have 35%. If you don't, just write 0.35. So 35% of 420 should give us 147 cakes. So far, this is the number of cakes we have of vanilla and banana. And the last one, the ratio of the number of lemon cakes to the number of chocolate cakes is 4 to 5. So think of it like this. We have a total number of parts of 9. So this means 4 parts out of 9. So 4/9 are lemon and 5/9 are chocolate. And these add up to make 9 parts. So that's it. Work out the number of lemon cakes Daniel bakes. Alright, this is actually so easy. We could have just figured out 4/5. So let's have a look. So this is 4/9 of the grouping of cakes. Okay. So let's have a look. How many cakes do we have so far if we eliminate these two, yeah? So we got 420 minus 120 minus 147. What do we get? So 420 minus the 2 values. This means so far these 2 cakes account for exactly 153 cakes. So these are for both lemon and chocolate now, yeah? That's the remaining cakes. So we want to find 4/9 of 153. So let's put that in a calculator as well. So yeah, trust me, this can be really easy. You just have to take your time. And then you get 68. So this means 68 cakes to a lemon. And of course, you could do the same for chocolate, but we don't need to do that. Done. 5 marks for that. So that's easy 5. Alright, so number 5. Oh, this is tricky. So in the diagram, A, B, B, C, and C, D are 3 sides of a regular polygon P. Okay, for these kind of questions, make sure you know your interior exterior. So I'm going to go ahead and say the interior angle plus the exterior always adds up to 180. Just a quick recap, the interior is the inside and the exterior is like if you draw a dotted line would be the outside. So that's like a straight line. Another one we need to also consider is the sum of the interior angles. So the sum of the interior angles is always the number size minus 2 times 180. This essentially means how many triangles can you make in a certain shape. Like a square, it has 4 sides, so you can split it up, so you get 2 shapes. So 4 take away 2 is 2, 2 times 180 is 360, and it works, and it checks out. Anyway, let's just get back to the question, see what's going on. Show that polygon P, so this shape here, which is not complete, is actually a hexagon. You must show you're working out. Now, to show something is a hexagon, at least in this case a regular hexagon, we need to know how many, what do all angles in a hexagon add up to. So let's do the sum of the interior of a hexagon, yeah? So we know hexagon has 6 sides, so it'll be 6 minus 2 times 180. Put this in a calculator, and you should get exactly 720. So we know that the total number of angles should be 120. Now to find a single interior angle, because it's 6 sides, we can divide 720 by 6. So this will give us the angle of one interior angle. So divide that by 6. Oops, you should get 120 degrees. So this means that we need to prove that this angle here is 120 or this angle here is 120. If we can do that, we've done it. Now, how to do it? So let's look at the square and the 12-sided polygon. We know this is a perfect square, so all squares have a 90 degrees perfect right angle, so that's 90 off the bat. This is 90. Now we need to work out the angle of this one, of this 12-sided polygon. So let's do the same method I did for the hexagon. So find the sum of all the interior angles. So this is for the 12-sided shape. So the sum of the interior angles would be 12 minus 2 times 180. In the calculator, you should get 1,800 degrees. Now divide this to find one interior angle. So interior would be 1800 over 12. Let's see what that gives us. 150. Okay, so we know this is 150. Now let's just do the maths here, yeah? All angles around a point, so I'm just going to zoom in for a second. All angles around a point must equal 360 degrees, guys, yeah? What does that tell us? That means we just need to do the maths here. So 90 plus 150 will give us 240 degrees. This means to get to 360, we need to add 120 more. And that's it, guys. We've done it. We proved that this is a hexagon since we needed 120, and that is an interior angle. Voila, done. Okay, question 6. So check this out. So the density of apple juice is 1.05 grams per centimeter cubed. Okay, before we answer this, let's just go ahead and write the density formulas, yeah? So we can say that the density is always equal to the mass, which is represented in grams, per centimeter cube, which is a volume. So this is sometimes how I remember it. I just look at the information. If we say it's grams per centimeter cube, this means like literally mass per volume. It's a good way to memorize it. Okay, next one. So the density of fruit syrup is 1.4 grams per centimeter cubed. The density of carbonated water is 0.99. Now here's a new information. 25 centimeter cubes of volume of apple juice are mixed with 15 for syrup and 280 centimeter cube of carbonated water to form this drink of volume 320. So I was going to say add these up, but they already did the math for us. So essentially we could say that the total volume for this one, let's call it total V, equals 320. I have a feeling they want us to calculate even mass or density. Work out the density of the drink. Okay, thought so. Now just looking at this formula, the only way to get the density is to firstly work out the mass, the total mass. And to do that, we need to look at the information again. So let's rewrite this equation and make mass a subject. So this means that mass is going to equal, so just times volume across, density times volume, yeah? Now we're going to take it step by step and do each one. Let's find the mass of apple juice, yeah? So the mass of apple juice, this is going to be density times volume, so 1.05 times 25, and then the mass of, what is it, fruit syrup, this is going to be 1.4 times the fruit syrup, 15, and then same for carbonated water, yeah? Mass of carbonated water, CW, so 0.99 times 280. Okay, now all you do is work this out and then add up the total result, yeah? So let's do each one. So 1.05 times 25 gives us 26.25. 1.4 times 15 gives us 21. And 0.99 times 280 gives us 277.2. So adding all of this up in your calculator, you should get, okay, I got 324.45 grams. So this is the total mass here, total M. So now we just use the formula again. So the density says mass of volume. So this means that the total density is going to be the total mass, which is 324.45 over 320. And doing it and putting this in your calculator, you should get an answer roughly equal to 1.01 grams per centimeter cubed. Whew, not bad. So this one is a bit lengthy, but doable. Okay, 7. Pythagoras or trigonometry. So ABC is a right angle triangle. Calculate the length of AB. So X. It's called ABX. Give your answer correct 3 same figures. So this is good old trig. So when you think of a right angle triangle with angles and length, think of SOHCAHTOA, right, like all the time. And always ask yourself what is involved, what lengths are involved. So opposite 23, we have the opposite. So every angle opposite the angle is called the opposite, so called as O. And the long length here, the diagonal length, opposite right angle is always the hypotenuse. So clearly we got O and H and no adjacent. So cross out the adjacents. So we're using SO. And to write this out, it's always sine of the angle. So sine 23 equals opposite of adjacent. So opposite, which is X, adjacent, opposite of hypotenuse. Hypotenuse is 15. And now to solve this, just clear the fraction. So multiply 15 across and you should get 15 times sine 23. And that will be our X. And put this in the calculator. And you should get, to 3 centimeter figures, 5.86 centimeters. Easy, very easy stuff. Seriously, after coming from a long density question to trigger to just a nice SOHCAHTOA, it's a blessing. Let's hope the rest of the paper is like this. Right, let's do number 8 now. So we have a square with size of length x centimeters is inside a circle. Okay, so probably just do a little sketch. You got a square, right? Nice looking one is inside a circle. I'm just gonna guess it's touching the corners of each one. Okay, so just ignore these bits here. Okay, so here is the vertex, each of the corners. Now each vertex of the square is on the circumference of the circle. I mean, that just sounds usually a given. It's always like this. The area of the circle is 49 centimeters squared. So let's just keep that in mind. So area of the circle is 49 centimeters. Work out the value of x. Okay, so let's just label this. So each length is x. The area of the circle is 49 centimeters squared. Work out the length. Now let's just talk about the area of each one, yeah? So the area of a circle is always pi r squared. Okay? And just look at it carefully. If we drew like a point here, we can say that the radius is like this, right? So the radius is r. And we can see that if we just did this a bit carefully, if this whole length is x, that means half of this length up to here only is x over 2. And because it's a square, this length here is also x over 2. So essentially, we can find the radius here. So we could say, using Pythagoras Theorem, so just pull out this triangle here. We have x over 2, and r. We could say that using Pythagoras Theorem, r squared equals, so a squared plus b squared c squared. So we've got x over 2 squared plus another x over 2 squared, and I know the algebra is kind of mad, equals r squared. Now the question is, we need to work out the radius first. And thankfully we've got the area of a circle. We know that pi r squared must equal 49. So putting this in your calculator, so dividing by pi and square rooting. So I'll do it here. So r equals 49 divided by pi and then square rooting, you can get an answer. So let's see. Actually, you know what? You don't even need to worry about that. Just find r squared and plug it in. So if r is that, r squared was 49 over pi. We can just substitute this into here. So this means our equation now becomes, so guys, just take your time with this. 49 over pi equals, and then copy the rest, x over 2 squared plus, oh yeah, because you got two of them, it's just two lots of them. 2 lots of x over 2 squares. Okay, now what do we do? So they want it to 3 similar figures, right? So let's just literally solve this for x. So what you want to do is firstly divide, get rid of that 2, so divide 2 across. So you get 49 over 2 pi equals x over 2 squared. Then square root this answer, so you're going to get 49 over 2 pi square rooted equals x over 2. And then multiply 2 across. So you're going to have 2 times square root of 49 over 2 pi. And this is our x. Now guys, just smash that in the calculator and just pray that's alright. So let's see, 49 over 2 pi. My advice for questions like this, only rearrange everything first and just literally smash in the calculator. Don't do it like ahead of time. Anyway, I did this and I got to what is it? To 3 similar figures, 5.59. That's it. Yep, looks good to me. Yeah, perfect. Alright, next one, number 9 now. So hopefully, remember, for any questions, guys, if you're stuck, just literally shout, just give me a message in the comment below, and yeah, we'll try and take it from there. Anyway, number 9. The box plot shows information about the distribution of the amounts of money spent by some male students on their holidays. So quick recap here, values here. So the length here is known as the minimum and the maximum. So the highest and lowest values taken. The middle quadrant here is the median. And these two lengths, you can probably guess, is the lower quartile and the upper quartile. Perfect. Now, work out the interquartile range for the amounts of money spent by these male students. This is quite okay. We just need to probably zoom in just a bit. So I guess that line kind of ruined it. So the interquartile range is the difference between the quartiles. So we can say IQR equals upper quartile minus lower quartile. Okay, so the upper quartile here, so let's have a look at the values. Yeah, so we got 300. So this is going up in actually 20s. If you're not sure, just find the difference between 400 and 300, which is 100. Divided by 5 squares, you get 20. So let's see, we've got 300, 320, this is 330 I think, yeah? Upper quartile is 330. Lower quartile is bang in the middle of 100 and 200, so 150. And that's it. Put that in the calculator. And I got 180. Right, cool. So 180, so zoom back out. Nice. Okay, the table below shows information about the distribution of the amounts of money spent by some females on their holidays. Sorry, I just had to close the window, so much noise. So here's the money spent. Okay, so actually this is the same data. This is about males, yeah? This is females. So on the grid above, draw a box plot for the information in the table. Okay, so first things first, draw the ranges. So we've got the smallest, the minimum value, which is 60, and the maximum, which is 650. So this one's quite relaxing. I had to, let me just get rid of all of this. So here you have to be very careful how you draw, yeah? Make sure you guys use a ruler, yeah? So 60 should be here. Okay, I have to kind of waste some time here. So you got 20, 40, 60. So let's say it's over here. I'm just going to make this the line, yeah? So this is the female students. And then 650 is bang in the middle, so it's from, let's just say from here, yeah? Okay, next ones. The low quartile is 180 and the upper quartile is 350. So 180 is 200, 180 is here. So again, so we have to connect the line together. And the upper quartile was 350. So that's between 300 and 400, so over here. And you can just connect them like that. Now lastly, we need the median value. So the median here is 300. So it's more skewed to the right. That's it. We're done. Okay. All right. Okay, part C. So Chris says the box plots show that the female students spend more money than male students. So let's just have a look at the box one more time. Now, on average, it looks like females spend, and oh, by the way, when it comes to averages, we look at means. And because if we don't have mean, we look at the next best thing, which is the median. Okay? So according to this data, women, the line seems to be further up ahead, so women spend more at 300 and males spends a bit less at 250. So we can say, like, clearly according to this, that women spend more than men on holidays by £50, according to their medians. So yes, women, or female students actually, that's because we're talking about female students. Female students spend more money on average than their male counterparts. Why not? The male students, you want to keep it easy. And at 300, again, 300 and 250 respectively. So yeah, just say in your own words. I admit this reasoning kind of sucks, but hey, more or less, females spend more than males on average at 300 against 250 respectively. That's clear enough, like, for anyone to understand it. Okay, number 10 now. Back to some simple maths, yeah? So now would be invest £6,000 for 5 years. And whoever's got this name, I apologize if I pronounced it wrong. This name is really cool. So the investment gets compound interest of X% per annum. At the end of 5 years, the investment is worth £8,029.35. Work out the value of X. Alright, this one's very easy. I always use this general formula, which is the original value times 1 plus or minus a rate equals a new value. And if you got the number years, we put the number years as a power. You don't learn this in school, but this is a unique formula I use for most of my compound interest or percentage videos. The original value is always the first value, which is like 6,000. The rate we don't know, but because we know it's compounding, it's going to be an increase. It'll be a positive rate, so it'll be 1 plus the rate being X%. And the number years is going to be 5. And we know that the end investment is going to be £8,029.35. So all you want to do is solve this, like, literally algebraically. So just find the value of X%. Let's do it. Let's do this. So first things first, let's divide 6,000 across. So we're going to have 1 plus X% all to the power 5 equals 8,029.35 over 6,000. We can solve this as we go. Next, we want to get rid of the fifth root, so cross this out and find the fifth root. So fifth root is literally stick a 5 there, yeah? Next, we want to subtract 1, so it'll be X% equals the fifth root. So remember, use the cube root button and delete the 3.5 of this number minus 1. Okay, and just to be a quick recap, if you find this a bit annoying, X% literally means percent means per 100 in French, so X over 100. So after this, whatever your answer is here, times your result by 100 to get just X. So I'm going to go ahead and do this, so bear me a second. So let's see if we get the same result. So the fifth root of this, put in a calculator, and you should get, let's say X equals 6. So the answer would be 6%. Okay. Good. Okay, question 11, guys. So Jeff is choosing a shrub and a rose tree for his garden. Okay, this one seems quite fun. At the garden center, there are 17 different types of shrubs and some rose trees. Okay, so 17 times some random variables, yeah? Now, according to this, he says that there are 215 different ways to choose one shrub and one rose tree. So essentially, just to understand what this means, this is telling us that out of the 17 different types of shrubs, he's going to buy a certain quantity that will give us 215. So to write this in like mathematical terms, we simply say that 17 times some number of plants he's going to buy is going to give us 215. Okay, and well, for this to be correct, n has to be a whole number. Alright, that's the only thing that would make sense. So let's work this out. So dividing 17, what does that give us? Well, I did it, and well, you get about you get a weird answer. You get 12.647 dot dot dot. Now this doesn't make sense because the number of plants he needs to buy would either be between this 12 13. You cannot buy 12.647 plants because it doesn't make sense. So could Jeff be correct? No. He probably made a mistake. He probably bought 17 times 12 plants or 17 times 13 plants. He needs a whole number. So we say that n is not a whole number. So always give yourself like clear answer of why it doesn't work. That's it really. Okay guys, number 12. I had an attempt on this one. This question is quite a fun looking question. It just takes a bit of thinking here. So let's have a look. The points A, B, C, and D lie in order of a straight line. So in numerical order, yeah? Or at least in order straight line. So according to this one, the line AB to BD is proportional or equal to 1 to 5. The line AC to CD is 7 to 11. So this is the number of parts it corresponds. Now notice how it starts from A and ends in D. So these two are pretty much equal in some form. Now work out the three-way ratio. The line AB to BC to CD. Ooh. Okay, my tip for this one, guys, do what it says. It says in order of a straight line. So I would straight away draw a straight line and just label some points. So A, B, C, and D, just for the sake of visualizing it. Now, I'm just going to think of it this way, yeah? The only way to get this solved properly is to somehow make these equal in some form, yeah? We could say that, let's write A, B, and B in terms of x. We can say that from 1 to 5, this is same as 1x to 5x, meaning the total parts is 6x. And we can write in terms of y for the second. We could say 7y to 11y, add them up will give us 18y. So essentially, we have 6x equals 18y because their length is the same from A to D. Now, writing this in terms of length, we could say that, okay, so AB to BD, so if this is 1x, and this length is 5, so this whole thing is 5x. Now, same for AC. AC is from here to here, which has a length of 7y, or 7 parts. And CD has a length of 11 parts. Well, that's quite small. So now we just more or less equate these. So we can say, okay, so the total on the top half equals the total on the bottom half. So 6x must equal 18y. Okay. Now, it depends how you want to do this. You can just, I would just simplify this, yeah? I would say if I divided this by 3, I could say that x, or divided by 6, I could say x would equal 3y. So if I was to update these values here, let's change color pen, I could say now that x is literally 3y, 5x is 5 times 3, which is 15y. So looking at its head on, we can say that the length from A to B now is 3 parts. So let's work in terms of y, yeah? We can say that A to B is 3 parts in terms of y. B to C is going to be the difference between, let's have a look. So, oh yeah, it's the difference between 15y and 11y, so it's 4 parts. And then C to D is 11 parts, so it's 3, 4, and 11. Okay, question 13. Ooh. So write down 3 inequalities that define the shaded region. Okay, so graphing. So what this means is that we just need to firstly, before we even think about inequalities, is to figure out what these line equations even are, because they give you nothing, unfortunately. Now looking at the easiest line, which is this dark line here at -2. This is essentially y equals -2. So this is the y equals -2 line. Okay, we're going to get to the inequality part in a second. Now the tricky part is to figure out these two lines. Okay, now my tip for this one is to always pick 2 coordinates on that line and 1 coordinate on that line and see where it intersects on the y-axis. For example, for this equation here, it intersects at 0. This line intersects at 0, so we can call it y equals mx plus 0, or just y equals mx. Whereas this line here hits the y-axis at 1, so it's literally y equals mx plus 1. Okay, just a quick recap. The general equation is always mx plus c, so c is the y-intercept. Now m is the gradient here, so to find the gradient, just pick any coordinate on these lines. I'm just going to pick 2, 2, because they're both on 2, 2. So we could say when x is 2, okay, at 2, 2, it probably makes more sense. So we say at 2, 2. So when x is 2, y is 2. This essentially means that when you plug in 2 and 2 here for the first equation, you're going to have 2 equals m times 2. If you solve this, divide by 2, you get m equals 1. So the gradient is 1. So this equation becomes y equals 1x, or just y equals x. For the second equation, at 2, 2, let's put over here, at 2, 2. If you plug it in, you're going to have 2 equals m times 2, which is 2m, plus 1, and what's our one? Y equals minus 2. Right, so, oh man, I hate graphs so much. So, the way this works, we have to see how to obtain its area. My tip is always rearrange the equation in terms of y, we did that. In terms of x, make y the subject, and then just see if it's above or below. For this one, the shaded region is above. If it's above, we use the greater sign, yep. So we can see, because it's above, we can say that we have y greater equal minus 2. Okay. If you tilt your head for this line, the y equals x line, so this line, the one that cuts through 0, if you twist your head angling and just imagine this line is the x-axis, yeah, you can see that the blue line is above it, so this would be a greater sign too. So this would be y greater equal than x. This is just like a visual way of looking at it. Now if you look at this other line, the more slanted line, which is y equals half x plus 1, and just bend your head, make this look like the x-axis, you can see that the blue one is underneath it, it's below it, so it'll be less than. So it'll be y less than equal half x plus 1. And that's it. These are literally your 3 inequalities. Okay. Hopefully we don't get no more of that now. Now 14. Let's check this out. So simplify x squared minus 16 over 2x squared minus 5x minus 12. Oof, I love it. 2 quadratics. Now first thing you got to spot is that the top one is a type of difference of 2 squares. Like, how do we know? We literally have one thing squared minus another squared, meaning this is a straight up double bracket problem with a plus minus result. So always put xx because x squared, and then we just say the square root of 16 is plus 4 minus 4, and you're done. Now the second one's a bit more tricky, but one thing I've noticed by these questions, if you have 2x squared, one has 2x in the bracket and other one has x, and usually the smart thing in these questions that they always, one of the results at the bottom is usually the same as the top. So this x could be minus 4 or plus 4. It's usually like an exam technique. Now, how to do this? So let's think of two numbers that multiply to make 12. Okay, so two numbers multiplied to make 12 would be 3 times 4. Now we know it's going to be a 4 there because of exam technique. And let's have a look. So to get exactly 4 and to get 3 here, so this means, like, out of just a guessing, we could put 3 there to just check. Now let's see if we can get this result. So if we do 2x times 4, this will give us a 8x, and 3 times x is a 3x. So yeah, and to get a minus 5x, we need to subtract, so it'll be a minus 8x plus 3x. So essentially it'll be 2x times 4, which would be minus 8x, and then a plus 3x. That's it. Oh man, it's tongue twisters here. Now you just cancel down, bang bang, and you get x plus 4 over 2x plus 3. Yeah, hope you're not following this because sometimes it gets intense. Now, so exam technique, always try and copy what they did on top and just do some trial and error. Trust me, it always works. Now, oh, another lovely one, make v the subject. So first things first, clear out the fractions, so throw v across, so you can get VW, Volkswagen, times 15 and expand the bracket, 15t minus 30v. Now to solve this easily, to make v the subject, throw all your v terms to the left. Okay, so I'm not, no song here, throw to the left, so minus 30v, throw to the left would be a plus 30v, so VW plus 30v. So the common technique is to throw all the terms you want on the left and the terms you don't want on the right, like the non-v terms like t. Now this is very important. Over here, to isolate the v's or to get them out, you need to factorize v out. So it'll be v bracket w plus 30 equals 15t, and we're done. Now we just literally throw w plus 30 underneath. So you got divided across, you got 15t over w plus 30. Done. Alright, that was cool. Let's move on to the next bit. Let me see if it's all good. Yeah, we didn't miss nothing out. Alright, okay. Okay, so now this looks like a good old cosine rule, I'm guessing, or area triangle. Okay, how many marks? 5 marks. This is actually quite easy. So the area of a triangle ABC is 6 root 3. So just a quick recap. When you have a triangle in this form, or you have a length here, another length here, and an angle between it, we use the area of a triangle formula, which is half AB sine C. So make sure you remember this, guys. Yeah, very useful. So, and we have it here. We have two lengths and angle between, so we can use this. So calculate the value x. Okay, so using the formula, we're gonna have half AB. So let's say half x plus 3 times the other length, 2x minus 1, sine 45. And we know the area of this must equal 6 root 2. Okay, so yeah, now this is just algebra, guys. So just to make it easy for you, my advice is to throw the half and sine 45 to the right side, so you can expand this normal double bracket problem. So we're gonna have x plus 3, and then 2x minus 1 equals now 6 root 2 over half times sine 45. Literally throw this in the bracket in the calculus, all this entire calculation on the right. Yeah, so basically what I'm trying to show you here, guys, is like fast methods to get this done quickly. Anyway, when you do this, all of this actually becomes 24. So all of this on the right side is now 24. Yeah, it's pretty convenient that way. Okay, so now let's expand the double bracket using FOIL method. So remember, I'll draw the arrows, so it'll be x times 2x and then x times minus 1. Then we've got 3 times 2x and 3 times minus 1. So doing this, x times 2x is 2x squared, x times minus 1 is minus x, 3 and 2x make 6x, 3 and minus 1, negative 3. And all this equals 24. Now, all we want to do now is throw it into the standard quadratic form, which is throw everything to the left and collect terms. So doing that, we have the x squared term, which is 2x squared. We have minus x plus 6x, which is plus 5x. We've got minus 3, subtract 24, we get minus 27. Done. Now, finally, to solve this, use a quadratic formula. So quadratic formula looks like this. It's always minus b plus minus the square root of b squared minus 4ac over 2a, where a, b, c are these values for each one. So no, not minus 2, minus 27. So a in this case would be 2, b is going to be a 5, and c is going to be a negative 27. Yeah, I just need to catch my breath soon. So yeah, and plus I'm doing this when I'm fasting as well, so it's actually a nice little challenge for myself. So anyway, so hope you guys are following this well. We're going to try and get the answer now. So plug this in the calculator as well, yeah? So replacing the values, minus b, so it'll be minus 5 plus minus b squared, so it'll be 5 squared minus 4 bracket a, which is 2, c, which is minus 27. Quick tip, guys, yeah? When you're substituting numbers for letters, always wrap them in a nice bracket so you avoid the error in the calculator. And this is all over 2 times 2. Okay. Let's work this out now. So what do we have? So we got minus 5 plus. So I'm also going to do this as well. So let's see what we all get. Minus 27 over 2 times 2. Okay, so my first answer, when I use the plus sign, I got 2.63. Let me just see what they want. Do they want 1 answer or 2? Correct value of x. Okay. Okay, word a tip. You'll get 2 answers, plus or minus, but just know which one's right. Because you're working with lengths, x plus 3 needs to be positive, yeah? So you need a positive length, not negative. If you had the negative result, put the minus sign, you would have got like minus 5.13. So this is the other result. But this is wrong because you can't have negative lengths. Yeah, so the answer is 6.23, guys. Done. Oh. Okay, 16. Iteration. These are giveaway marks. I'll show you guys a cool trick. In your calculator, you could make sure you abuse the answer button for these ones because it works so well. What I would do is firstly, in your calculator, enter this x equals minus 2.5. So just write minus 2.5 and then press equal. So now your answer currently is minus 2.5. Now, what I want you guys to do for this iteration method is to just rewrite this equation now. So let's call this x1, yeah? x1 is going to be minus 2 minus 4 over, and you see this xn squared. In your calculator, you're going to leave it as answer squared, okay? And then once you do that, if you just copy this in and just literally smash equal consistently, the first answer you're going to get is minus 2.64. Now, whatever you do, okay, not minus, should be, hold on. Yeah, so you should get an answer of minus 2.64. And then when you do that, do not delete nothing. Just press the answer button again, and you're going to get minus 2.57392-ish. And then press answer again, you get the next one. So what's happening here is that it's using the new answer into this as this answer formula. So the new answer replaces the current answer. And if you literally just keep smashing equal, you're going to keep getting the next number onwards. Honestly, this is a good skill, so make sure you just practice that. That's it, and this is literally easy 3 marks. Okay, now next question. Explain the relationship between the values of x1, x2, and x3. Okay, all right, let's have a look. So what do we get? So first things first, we started at minus 2.5, yeah? It went quite down to minus 6.4, then it went up to minus 2.57, then it went down. So what's actually happening here is that it's trying to actually estimate the true closest value for these values that will give us a true solution of 0. Okay, so that's what it's doing. It's literally solving to find the best value estimate. So we can say the relationship would be is that this iteration method is recycling, you can write this in your words, the values of x to return the next best estimates to give the best value of x, and then this is going to correspond to a solution of 0. Okay, so this is more or less, so you can think of this as iteration as an estimation method. Yeah, that's the estimation method. Cool. Okay, 17 now, almost done, guys, almost done. So a train traveled along a track in 110 minutes. Okay, corrected nearest 5 minutes. Oh, it sounds like bounds. Jake finds out that the track is 270 kilometers long. He assumes that the track has been measured correct to the nearest 10 kilometers. So quick word, yeah, quick advice. When they use the term nearest somethings, in this case nearest 5 minutes, you always half this value and treat it as a bound. So plus minus half of 5 is 2.5 minutes. So that would be like the bound for 110. It could be, the upper bound could be 112.5 minutes or 107.5 minutes, plus minus that, yeah. Same for this one. The track is 270 kilometers, and to the nearest 10, this is plus minus 5 kilometers. Again, upper and lower bound. So always half these figures. Could the average speed of the train have been greater than 160 kilometers per hour? You must show how you get your answer. Now, for this kind of question, the only way to ensure that this is true is that you want to find possibly the greatest speed this could have achieved using the bounds. Now, let's write down the speed formula. The average speed formula is always distance over time. Now, the way this works, you need to find the greatest ratio is always going to be the greatest value for the top half of the fraction, so the upper bound of the distance, over the lower bound of the time. Reason why is because the smaller the value on the lower half of the fraction, then the greater the overall result will be. So you want to maximize the top, minimize the bottom to get the greatest upper bound of speed. So the upper bound of distance, that means is going to be, firstly, the distance was 270, so it'll be 270 plus the 5 kilometers, and the lower bound is going to be, what is it, time 110, is always in hours, right? Even annoying. So the convert in hours is not too bad. So we know that 60 minutes an hour, so you could write like this. So 110 minutes minus 2.5 minutes, and then just put this in bracket, divide by 60. This will convert to hours. So yeah, this should give you a result. So let's see what that gives you. So 270 plus 5, 110 minus 2.5 over 60. Oh, So the answer is no. Actually, the greatest value, the greatest speed he could have achieved, according to this one, is 153 point, let's just round up, 488 dot 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 kilometers per hour. So the answer is no. Yeah. Okay. So let's move on. Now Jake's assumption was wrong. Are you serious? You could have just looked down and the answer would be no. The track was measured correct to the nearest 5 kilometers. Okay, right, that's the assumption bit. Explain how this could affect your answer in part A. Now, just to make your life easy, it's probably best you just try and calculate again. So the nearest 10 kilometers means nearest 5 now, so it'll be plus minus 2. So this figure at the top is reduced. So essentially we're going to have now 270 plus 2.5 over the same result. 110 minus 2.5 over 60. So because the value has been reduced, this means we're going to have a lower average speed. But just let's confirm this anyway. So plus 2.5 over, because the truth is with these kind of questions, it's always good to give a numerical proof, because that always guarantees things. Anyway, I did it and I got a slightly lower speed of 152. So you can say this reduces the average speed as the numerator has decreased. Yep, easy. And you can say holding other things constant, as in the denominator, yeah? Okay, 80 now, almost done guys. I just went through the bottom of the paper and noticed that there's only 20 questions, so that's quite good. And the last 3 seem pretty okay, especially this one. This is quite cool. Right, let's check it out. So A, B, and C are points on the circle of radius 5 and center O. Okay, so radius is 5. So, you know, before I even read the rest of this, I'll just go ahead and define properties. So here we got a tangent, yeah? So tangent is when it hits the circle. It's a straight line equation, it hits the circle once. Every time it hits a circle, it's always 90 degrees to the center. So this is a circle geometry property, yeah? It's 90, so it's right angled here. Okay, and yeah, that's all we need to take from here. Okay, so DA and DC are tangents to a circle. Now the length DO is 9, so this length is 9. So that actually helps a lot. Work out the length of the arc ABC. So arc ABC. Now to work out this arc, we kind of need to find an angle here first. And to get an angle here, we should of course find the interior angle inside here first. Okay, so before we do that, let's see what we can find, yeah? So we have a right angle triangle, we have 5 and 9. This looks like trigonometry to me. So let's work out this length. So let's pull this triangle to the right, call this 5 and call this 9. Now, what do we have? So to work out this angle, let's call it X. So let's have a look. So here, this length will be the opposite. That means the one next to it is going to be the adjacent. So this is the adjacent and this is the hypotenuse. So using good old SOHCAHTOA, like the previous time, we don't need opposite, so SOA is gone and TOA is gone. So we have cos X equals the adjacent 5 over hypotenuse 9. So 5 over 9. Yeah, and now all you have to do here is, to get X, we have to cos inverse this result. So let's cos inverse it. Okay. And here you get 56 degrees. So what do you want? So let's round out. So 56.3 degrees. Okay. And well, let's call it 2.5 because I've noticed that you would have to double it anyway. So probably not best not to round it for a bit, yeah? Now using your answer, so this is 56.25 and that means doubling it, we get the full angle. So let's double our result. So times it by 2, your answer, and you should get, yeah, perfect, 112.5 degrees. Yeah, go away. That means if you take the angle behind it, so this is all angles around a point, so this is going to be 360 degrees in total. So do 360 minus your answer, you should get an angle of roughly 247.5 degrees. So this is literally a massive arc now. like that. Little Pac-Man face. Now, the general formula for calculating the length of an arc is very easy. It's always going to be the angle of interest, so a fraction of the angle, in this case 247.5 over 360 times the circumference of the circle, which is 2 pi r. Now, thankfully, we know the radius, which is 5, so it'll be 2 pi times 5, so 10 pi essentially. So just put this in your calculator at r equals 5, the radius is 5, and see what you get. So answer over 360, oh not 390, 360 times literally 10 pi, and you should get the three significant figures, 21.6 centimeters. Yeah, perfect, easy. I think this was quite easy actually for an 18 mark, for question 18 or 5 marker one. Okay, 19. Solve this quadratic inequality. So as always, try and factorize this if we can. So attempting to factorize, just to have a go. Because the number is 2, the only possibility to find the product of 2 is 2 times 1, so it'll be 2 and 1. Now using this pairs, can we get a 3x? Well, let me see. If you put 2 here and 1 here, what do we have? So this is trial and error, guys. You put 1 and 2 or 2 and 1. So you got 2x times 2, which is a 4x, 1 times x, which is 1x. So yes, you can get 3x. If you did 4x, take away x. So this has to be a minus and a plus, because plus 4x, take away 1x, gives you 3x. Okay, not bad. Okay, so now we're done. Now we factorize everything. We just simply have to solve this now. So firstly, what do we have? So we got 2x minus 1, which is equal to 0, and x plus 2 equal to 0. Solving this, just make x a subject. So plussing 1 divided by 2, you get half here, and doing the same here, you get negative 2. So these are your critical values. Now, we need to determine what x values around these points makes the solution positive. So to do that, just draw a number line, put this value minus 2 here, and the value of half there. Now, this is a really cool method. All you have to do here is literally pick some points here, yeah? And between these two values and behind minus 2 and greater than half, that makes it positive, and see if the answer is positive. Let's do an example. Let's pick 0, because 0 is between this. So let's pick this region, yeah? Figure out if this region's positive. When you plug in 0, what do you get? You get 0 plus 0 minus 2. Is that greater than 0? No, it's false. So then this region is false, so it's not in this region. So let's check this value here. Let's put value less than minus 2. Let's just say minus 3, yeah? If you plug in minus 3, what do you get in the calculator? So in the calculator, write it like this. 2 times minus 3 squared plus 3 times minus 3 minus 2. So what do we get there? Minus 3 squared plus 3 minus 3 minus 2. So I get 7. So yes, 7 is bigger than 0, so it's true. So this is true. So we're going to keep this region. So this is one region. And then we do the same on this side. So let's pick a number bigger than half. Let's say 1, because that's easy to work with. So we're going to have 2 times 1 squared, so it'll be 2 plus 3. So you can get 3. The result would be 3, and that's bigger than 0. So yes, this is true. So when this happens, the answer, then you can say that means x values can be on the left side, so less than minus 2, or x values can be bigger than half. That's what it means. So we can keep all answers bigger than half, all answers less than minus 2, but no answers between. And that's it. So this is a useful method. I really recommend you guys learn this line method. It's so easy. Just test 3 numbers and see what's true and false. And that's it. It's also good for the inequality shadings as well. We can try that next time as well. Alright, so let's move on to number 20, the final question. Okay, so I'm going to have a think about this one. So the equation of a curve is y equals a to the power x. So just a quick recap, a to the x looks a bit like that. It's a power graph, and you can think of it as when x is 0, you get a solution of 1. Because y equals a to the power 0 is 1. So when x is 0. Now, so a is the point where the curve intersects y-axis. Actually, I just done it. It's 1. State the coordinates of a, 0, 1. Okay, alright, that was easy. Alright, the equation of a circle is x squared plus y squared equals 16. The circle C is translated by the vector 3, 0. So it's moving to the right by 3, down by y. And it doesn't move at all to give circle B. So this means that this equation is now going to be, so if you move 3 to the right, it means x squared minus 3, by the way. So, x minus 3 all squared. So change x squared to x minus 3 squared. And y squared doesn't change. And the radius, well, it's still 16 because it's still the same circle. Because it's only moving, so the radius will be the same. R squared, that is. So draw a sketch of circle B, label with coordinates the center of circle B, and any points of intersection with the x-axis. Okay. Oh, do you have like a graph? Oh, you don't. Okay, that sucks. So let's have a go at this. So initially the circle was in the middle. So x squared plus y squared equals 16, meaning the centers was 0. Okay, if you're not sure how the equations look like, this is the general form of a circle. It's x minus a squared plus y minus b squared equals r squared. Where a is where AB is the center, so in this case it will be 3, 0, and r is the radius. So in this case we can say that the center of our equation is 3, 0, and the radius, so 16 equals r squared, so square root 16 you get 4, radius is 4. Okay, so this is just general properties, yeah? So this means that our center is going to be 3 to the right, so somewhere here, isn't it? We know that because the radius is 4, it's going to stretch up to minus 1. And it's going to stretch all the way up to 7 here, yeah? So this is just some vertex. So we just have to draw like a nice circle. Oh, okay, that's awful. A nice circle that looks a bit, and it curves at the right places. So look how it looks like an oval. So probably use a compass, yeah? I mean, I'm not sure if you have to use a compass, but probably do it. Okay, anyway, so all you have to say is minus 1, 7, and 3. You don't have to say nothing for the y-axis because it says label of coordinates, the center of the circle B, which we did. Any points of intersection of the x-axis we did is minus 1 and 7 because the radius is 4 on both sides. And here we don't. If you were to solve the y-axis anyway, all you would have to do is see when it hits the y-axis. So it intersects when x is 0. So you plug in x is 0 and you would solve for y. Again, you get a quadratic, but we don't need to do that. Anyway, I think that's it, guys, and thank you for watching the video. And I'm just going to rest now. So good luck with your paper, and let me know how it goes, and leave a comment. Let me know if there's any questions that was ambiguous or unclear or not as well as explained, and I'll do my best to help. Anyway, see you guys next time, and ciao.